In 3.5 equivalent statements, what we are going to be learning about, besides the conditional and biconditional, would be how to rewrite those in equivalent way or form using the converse, inverse, contrapositives. So let's get started. Equivalent compound statements. It says, show that P or not Q, and if not P, then not Q, are equivalent. So one of the ways that we can show that they are equivalent or even not equivalent is to do a truth table and to compare the column results for both of those statements. And then it says, use the result from part A, which is this part right here, to find or to write a statement that is equivalent to, and this is your part B. So our statement says the bill receives majority approval or the bill does not become law, and that's going to be part B. So let's first take a look and see what we need to do to find the truth table for each one of those statements, those compound statements. And so if I wanted to, I need to look at perhaps I need a not P for the second compound statement, and I need a not Q for both of those statements. And I'll take the first statement, P or not Q, and we're going to take this column and compare it with the next column. If P, then not Q. So in order to fill out the not P column, we focus again on the P column, and we write the opposite. So we have two falses and two trues. To find the negation of Q, we look at the Q column and we write down the opposite truth value. False, true, false, true. What I will do next is to look at this disjunction, or remember the condition for disjunctions. It states that if both are false, the answer is false. So in this case here, I have to look at my P column. Let me mark this for us right here. I'm going to look at the P column and the not Q. And I'm looking for false to false. The only time I see that is P is false and not Q is false on that third case, and that will give me a false result. All the other options will give me true. The next statement is the conditional. And let me switch colors on that. On the conditional, remember we want to look at not P. So that would be this column right here, and not Q. Column right there. For the conditional, it says that if you start with a true, which implies a false, the answer would be false. So the only time I have that occurring would be when not P is true, when not P is true, and not Q is false. This will give me a result of false. All the other options will result with true. So at this point, if you look at both of these statements and their truth values, you can see that they are identical. So these are equivalent. Right? These are equivalent statements. Both of these have the same truth value. Two truths, a false, and a true. So now it says to use the results that we just have, now that we know the statements are equivalent, to write a statement that is equivalent to this original statement they gave us. So let me go up here and give myself some room. me do some erasing. And I'll insert the equivalent statement. So this original statement is actually this first one, P or not Q. The bill receives majority approval or the bill does not become law. And since the second statement is equivalent, we are going to use the conditional to rewrite it. And so we have if not P. So we need to make sure and put if the bill does not receive majority approval, then we have the conditional. So we'll write then, and we have not Q. Not Q is the bill does not become law. All right, so those are equivalent statements. If the bill does not receive majority approval, then the bill does not become law. Is the same as the original statement. The bill receives majority approval or the bill does not become law, since they're equivalent statements. Show that the negation of P is equivalent. So that symbol means is equivalent. Is equivalent to P. So first of all, you need to find what's inside parentheses and the opposite of P. If P is true, the negation is false. If P is false, the negation is true. And then we're going to focus on that second column, and we're going to find the negation of the second column. So this is the negation of the second column. So if the second column is false, the third column will be true. If the second column is true, the opposite would be false. And what they're showing is that P and the opposite of not P is equivalent. And you prove that with the truth table. So for this problem, it's asking us to select the statement that is not equivalent to Miguel is blushing or sunburned. So first of all, they gave you your simple statements on the right-hand side. P is Miguel is blushing. Q is Miguel is sunburned. The original statement right here, we need to find out how to rewrite that into symbolic form. Miguel is blushing is P, or means a V. Sunburned is Q. And so since we're trying to find an equivalent way of saying P or Q for the disjunction, we need to go in and translate A, B, C, and D into symbolic form so that we can go in and do our truth table for each one of these. So let's look at A. A has if Miguel is blushing, if, that's going to P conditional, then he is not sunburned would be not Q. The next one, Miguel is sunburned or blushing. Miguel is sunburned is Q, or blushing is P. So now I have Q or P. Statement C, if Miguel is not blushing. If Miguel is not blushing, so this is not P conditional, then he is sunburned, which is just Q. Lastly, statement D is saying if Miguel is not sunburned, so this is not Q. If he is not sunburned, then he is blushing. All right, so we have all four statements, and what we'll do is go to the next slide, and I have already written out these four statements, and we will do the truth table to find out which one is not equivalent. As you can see, I already wrote out the truth tables and the columns of what we need. The original is listed, and then I have each of the 4 statements labeled A, B, C, and D. Remember, we're looking for the truth value that does not match the original. So let's do the original statement first. P or Q. Or states that if they are both false, if the P column and the Q column are both false, the result is false. That would be this last case right here. The rest of the cases will be true. So that is the original. The next one I'm looking at is I would like to get the not Q column completed so that I can complete the next statement. So not Q would make this false, true, false, true. Next, we're going to go for the conditional. P, this is part A right here. The conditional is if P, then not Q. So we're going to look at the P column and the not Q column. On a conditional, if we start true and it turns to false, such as the very first case, we have a true is P, not Q is false, that will give me a result of false. Any other option will give me true. We can almost stop right there because that is the one that does not match. But let's go ahead and finish these out so that you can get good practice. Let me erase what I can around here. All right, the next one we want to look at is the B statement, and it says Q or P. Remember, for the disjunction, if they're both false, the answer is false. So that one is going to look just like the original. In order to complete part C, I need a not P. So in writing not P, I will write 2 falses, 2 trues. Remember, this is just the opposite of the P column. I will rewrite my Q column. And now I will go for my C statement. If not P, then Q. If not P, then Q. The conditional, if it starts true and it turns to false, this is the only time it will be false. The rest of the cases that do not match that will be true. To complete the last statement, I need a not Q column, which we have already written. And it looks like I erased a little bit up there, so let me get that back up. This is false, true, false, true. The P column is a rewrite also, 2 trues and 2 falses. And now I'm doing my conditional. If not Q, then P. If not Q, then P. So if a conditional starts out true and it goes to a false, the result will be a false. All other cases that do not match those conditions will be true. So in looking at your original statement, 3 trues followed by a false, we can see that option C will match, B and D all match. So the statement that does not match would be statement A. So P implies not Q is not equivalent. And this would be your final answer for this problem. A conditional statement and its equivalent, contrapositive. So you can see up here it says if P implies Q is equivalent to not Q implies not P. And that is called the contrapositive. So this is your conditional. Get this truth table. This is conditional. And this one is contrapositive. So what they've done is completed a truth table for a conditional. You have your P and your Q column. You do your conditional, the arrow to the right here, and you get your truth value. True, false, true, true. Then you can write the contrapositive, which is basically, and I'll show you how to do this in just a second, is if you take your conditional and you reverse the sides that the P and the Q are on, and you take the negation of both of those, you now have the contrapositive. All right, so once again, all you have to do is take the negation and reverse sides. All right, so when they did the truth table for the contrapositive, they also came out with true, false, true, true. So since these are the same results, we can say these two statements are equivalent. Variations of the conditional statement. So you can see that if you have a conditional, which is if P then Q, and it shows me on this first statement here. You can also have a converse, which is basically reversing the P and the Q. If Q then P is the converse. The inverse is if not P, then not Q. And we just went over the contrapositive. If not Q, then not P. So notice from the table below, they have, and we already know this, that the conditional and the contrapositive are equivalent. There are two different ways to say the same thing. All right, we also have the converse and the inverse, which are also equivalent. And this is already indicated if you look on the table below. Those are equivalent, converse and inverse are equivalent, and they show the truth table to support that answer. All right, so once again, when you learn to take a statement and to rewrite it in an equivalent form, sometimes it's easier to understand and to interpret. And now we're going to practice on a few of these. Write the converse, inverse, and contrapositive of the statement below. If Charles Schulz did not write a sonata, then Snoopy danced a jig. So I would say that I can call Charles Schulz did write a sonata as my P. So I would go ahead and define this as not P. Then Snoopy danced a jig would be my Q. So once again, I called Charles Schulz did write a sonata as P. Q is Snoopy danced a jig. And now I have my symbolic form of that sentence. If not P, then Q. And what we'll take a look at first is the converse. All right, so on the converse, all we had to do was reverse the original statement. So instead of not P implies Q, I'm going to say Q implies not P. All we did was reverse the original. And now I need to find the statement that matches. So Q is if Snoopy danced a jig, if Snoopy danced a jig, then Charles Schulz did not write a sonata. And that will match D. So this statement here is right here, which is the converse. Next, we're going to take a look at the inverse. And if you look at the original statement, remember, focus, always go back to the original statement here. If I look at the original statement, I now have to just take the negation of both the left side and the right side. So the opposite of not P will make this a P, and the opposite of Q is not Q. So if P implies not Q is the inverse statement. Now we need to translate that into a sentence. We know that P is Charles Schulz did write a sonata, so that's what we're looking for, is if Charles Schulz wrote a sonata, then Snoopy did not dance a jig, and that is going to be A. The next one we want to take a look at is a contrapositive. Once again, let's go back to that original statement at the top. And we know how to do the contrapositive. We do the opposite of both sides and then reverse the sides. All right, so that will be Q comes over to the left. The not P goes to the right. And then we're going to do the negation of both sides. And when I clean that up just a little bit, I'll have not if not Q, then P. If you remember, we did this earlier. The opposite of not P is equivalent to P. So the statement that follows this is, if Snoopy did not dance the jig, then Charles Schulz wrote a sonata, and that would be answer B. Write the converse, inverse, and contrapositive of the statement below. So here is our original statement. If not P, then R. If not P, then R. First thing we're going to do is the converse of that statement. And if you recall, the converse says take the original statement and just reverse sides. So this is going to become the R goes to the left, the not P goes to the right. And that is going to match B. Next, we're going to do the inverse of the original statement. And the inverse of that is to take the negation of both sides. So I will write the original, if not P, then R. And now we have to take the negation of both sides. This is how you find the inverse. And after cleaning that up, we know the opposite of negative P makes that P, implies not R. And the answer that matches that will be A. Lastly, we will find the contrapositive of the original statement. And if we recall, that we have to do is take the original statement, not P implies R. We will reverse the order and then take the negation of both sides. We will do one more final rewrite. We have if not R, then P. If not R, then P matches answer C. And this concludes our lecture.